This is a video about conquering balancing practice for masters. So balancing practice for masters is this big worksheet I got from my chemistry teacher, and I learned a surefire method to get the right coefficients in front of the right variables every single time, and this is the algebraic method. So you may normally start out with a table like this one when you are setting up these balancing equations. But the problem with a table like this is that sometimes it's just too much trial and error, and if the clock is ticking down on your test, you probably don't want to use this trial and error method every time. So what I like to do is, instead of questioning what numbers do I put, I have this surefire method that works every time with these super difficult long equations. So the way we do this is we write out reactants and products, R and P, and you write down the elements that appear on both the reactant side and the product side. So here it's B, O, Na, and H. Then you assign variables to each of the parts of the problem. So here it's A, B, C, and D for where these spaces are, and those are the spaces that we're trying to fill in. So for reactants, what you do is you want to multiply what's B2 times A. Well, it would be 2A, because we're getting rid of that B, remember? We're trying to just set it up so that there's just these equations that we can use to plug in numbers to figure out what goes in front of these compounds. So first it would be 2A, because B2 and A, so 2A. The next one on the product side would just be C, because there's only one B on the product side. This would go on for the rest of them. As you can see, for example, Na, there's only one on the reactant side, so it would just be B. And for Na on the product side, there are 3 of them. So it would be 3C, because C is where it happens to line up. Now you set them all equal to each other, and you write out a system of equations, or you just solve the equations by plugging in number 1 for B. How did I know to plug 1 in for B? Well, that's because B shows up the most in these problems. So since B is in 3 out of the 4 equations, you want to plug in the variable for those 3 out of the 4 equations. So then you have a more likely chance of getting all the numbers you need. So as you can see, I got all the numbers I needed by plugging in 1 for B, and you want to plug in 1 because that's a really easy number to work with. I like to cross off the equations I've already used after using them. And then at the end, I multiplied everything by 6 because the fraction with the highest denominator is 6. For A is 1/6. You can't have 1/6 of an equation, so that's why you multiply everything by 6. So then the numbers in the coefficients, remember, it would be A is 1, because 1/6 times 6 is 1, and then you would do the same for all of the other variables and plug it in for those spots. Hopefully you can see what I mean with some more examples. So this next problem may be a little bit more challenging since we're going to be dealing with 5 spots to find now. So we would put the variables in for A, B, C, D, and E now, set up the reactants and products, set up the table with all the different elements that we're using, and then we also set up those nice equations to help us figure out what to solve for. So one of the tricky ones here is with H, because as you can see, H involves 3 and 2, so it would be 3A plus 2A, which is 5A on the reactant side. It's a little difficult. And then on the product side, it would just be 2D, because you can see the 2H is over there. And then another tricky one is for O at the bottom for oxygen. So the reactant side is pretty easy. As you can see, O2, that means there's 2 B's. But on the product side, there are 2 C's plus 1 D, because you can see that there's O2 on C and there's O on D. So you'd have to add those 2 together at the bottom. So those are our equations, and let's just do what we did last time. Set them all equal to each other. And then right off the bat, you can tell that C is 1, and then solve for D, solve for E, and then solve for B.